Hello everybody, this is Todd Frazee again, and this is the CAD tutorial for the S60-119 secondary piston part. Okay, so again, it's another part that'd make a lot of sense to revolve the base feature. You could extrude it and build it other ways, but I believe the least number of features would be revolving this first, cutting a slot in it, and then putting the hole in the hole through. So we're going to go to our drawing and take a look at it. Yeah, it looks like this one is its orientation is vertical, and in the front view you're looking straight on at the center hole with the slot in the side view and top view. So we would start with a profile that we would revolve that would reflect half of the part. So we would be picking off these diameters and the chamfer dimension and the overall height and this 0.13 dimension. Alright, so let's go to SolidWorks and set this up. Okay, so we're going to create a new part. Again, we're going to make our all of our planes visible. And this time I'm going to go ahead and sketch my center line first. So I'm going to sketch a center line on the front plane from origin, and we're just going to go some undetermined amount straight up, and it's constrained vertically. Its length is the only thing that's not constrained. And then if we're to draw the general shape of the part on the right side of this view, on the right side of this view, starting at origin, we would have a line going horizontal, one going vertical. We've got an angle. We don't really have a ledge, but we have it going straight up again to center line and then back home again to origin. So that's our general shape. I'm going to go ahead. Before we change the length of our center line, we want to throw our dimensional radiuses for their defined off diameters. So if I go from center line to the outside edge, I can drag my first diameter, which is 0.194 to 197. So we're going to shoot for the center of that, 0.195 and a half. 0.1955. Okay, so we've got our large diameter. You see this got a little funky, and that's just because of the scale of the dimension that changed. And this line is now on the wrong side of my center line. So I'm gonna exit dimension mode, and I'm just gonna drag that back over to the correct side. Okay, we're not gonna get too worried about it. And then we're gonna do the same thing with the next diameter. We're gonna select the center line, and then we're going to select our smaller outside diameter, drag to the left, gives us a diameter. And if we go back to our drawing, that diameter is 0.157. And that gives us the proper diameter. Okay, so this angled piece here, or chamfer, okay, we need to put a dimension on its angle. And it's a 45-degree chamfer, but with our angle tool, we're getting an included number. So it's really 90 degrees plus 45 for an inside dimension. So let's go 90 plus 45, and it gives us 135, which is the included angle we've got there. Okay, and now we should just need height dimensions because we haven't put any in. We go back to our drawing. The overall length of the part is 0.43, and then the distance between the top of the part and the top of the chamfer is 0.13. Start with the smaller dimensions first, or it smashes your sketch up and distorts it more as you're working on it. So I'm going to start with a 0.13, which is the dimension between here and here. So 0.13. It's going to get real short. And then we're going to do the overall height from the top all the way to origin plane. And that dimension is 0.43. Alright, so we should have everything constrained except for the center line. So let's go ahead and drag the center line down until it merges with the top of the part, and we should have a fully constrained sketch. This is what will revolve. So I'm going to exit the sketch. I'm going to rotate to a 3D view. We're going to keep the sketch highlighted, and we're going to go to Features, and we're going to make a Revolve Base. And it looks like it's auto selected, but if it doesn't do that for you, just select the left vertical line of the part, and that'll be your revolve. You want to go 360 degrees, accept that, and we have our base feature. Now, like before, I'm gonna make the standard planes invisible again. We may turn individual ones on, but it's just a little less cluttered. Okay, let's go back to our drawing. If I were to look at this in the front view, what features would we see in our drawing? So we have a hole that goes all the way through, and we have a slot. Okay, the drawing you may look like this. We're going to make a design change, so there's only one dimension for the hole, and it's going to be the smaller hole size. So for the purpose of modeling this, your hard copy may not have the second dimension on it, but at the time this video was recorded, there was the intention to have a press fit on one side and a slip fit on the other, and we've changed the intent to be just a press fit on both sides. So we're going to take this 161 to 159 number, and the number that would be halfway between there would be 0.06. So we're going to model our hole at 0.06, and it's going to be 0.059 from the end. So let's go back to SolidWorks, and we're going to make a sketch, and we're going to make it on the front plane. So we can still select it even though it wasn't visible off the feature tree. And we're going to make a circle, and we're going to draw that in the plane. And we can take a center line, and we can go from origin to the center of that circle. And if we force that to be vertical, it should be in line with the axis of the revolution of the part. And we're going to go back to our drawing and see where the location is. And the dimension for the center of that hole is 0.059 from the end. So we need to put in a dimension from the end. .059, accept that, and then we just need to give it a diameter, which was 0.06. Okay, so we should have a fully constrained sketch. We're going to exit the sketch, make sure the sketch is highlighted, And we're going to look at this from a 3D view. Now you notice the sketch that plane for the front plane runs down the center line of the part. So what we're going to do is we're going to do a feature. We're going to do an extruded cut. And it defaults to one side, of course, and blind. So we're going to make that through all. And then we're going to have a second direction, which is fortunate because in the software it's falling right on the tab for the VMware. So I'm going to minimize this for a second just so I can select a second direction. It's going to take the default depth that you had already set, so it goes through both sides. And I'm going to accept that. So now we should have a hole going all the way through the part. Okay, we have one more feature to make, and that is the slot in the end. So we're going to make that from the top view. We're going to go sketch, feature, select on the top of the part. Let's view the part from the sketch plane. And in this case, I'm going to switch our viewing to hidden line. Okay, we want to see where the hole is in orientation of the slot. So the slot we're cutting is opposite orientation as the hole. So the hole you're seeing in hidden lines is going vertically. We need to make our slot horizontal. So we're going to draw a rectangle that goes around center. Okay, and a quick way to center a box on a given point is to draw a construction line from corner to corner. And we highlight that construction line in origin, and we want it to be on the midpoint. So it puts the midpoint of this line that goes from corner to corner on origin, so that no matter what size this box becomes, it will always be centered on origin. Okay. So we need to put in a dimension for width, which on our drawing was 0.68 to 0.73. So if we go 0.0705 would be right down the middle. So we'll use that number. And then all the constraint we need is something to tell it that what the length of the box is. So we're just going to put in a number and accept that. And we should have a fully constrained sketch now. So what we're going to do is we're going to extrude that down until it hits this intersection here. Because I believe that's what it's dimensioned to. Yeah, it's 0.13. Okay, so we're just going to go with blind, and we're going to punch in 0.13 and accept, and we now have a cut. Let's switch our view back to solids with edges, and you should have that part finished. Okay, so that's it. You can add properties to it, material properties rendering if you like. But that's modeling the dash 119 secondary piston. Okay, I'll catch you on the next one.